Hello, and welcome to Train Signal. I'm Don Jones, and this is the Keys and Constraints lesson in the Database Administration Fundamentals course. In this lesson, we'll be talking about keys and constraints. We'll start with primary keys, move on to composite keys, and discuss the role of foreign keys. And I'll also help you understand the role of constraints. Now, you've heard the word primary key before. A primary key is a type of constraint on the database. It specifies that a column, or a combination of columns, is the primary key, or unique identifier, for that particular table. The constraint enforces unique values in that column, and it permits that column to be referenced as a foreign key constraint from another table. In many, if not most cases, entities don't have any truly unique attribute. People, for example, have attributes that other people could have: names, hair color, ages, birth dates, and so forth. And that's why databases tend to include made-up ID numbers as unique identifiers. They're simply the only thing that you can guarantee will be unique. Let's go into SQL Server Management Studio and take a look at a table design and add a primary key. For this example, I'll continue using my test database, and I want to create a new table. I'm going to use this to contain order information. So I'll have an ID that represents the order itself. That will be an integer, and I don't want it to be null. I'd actually like SQL Server to make up values for this, rather than me having to make up values as I insert new rows, so I'll create an identity specification. This simply means that I plan to use this column to uniquely identify each row. I'll have it start at order number 10,000 and increment by one order number at a time. I'm also going to right-click to set that as the primary key. I'll add a couple of other columns that we can play with, and I'll save this as my orders table. And that's really all you have to do to create a primary key. Right-click on the column that will uniquely identify each row. You do need to make sure that it will uniquely identify each row. That's very important. I have achieved that by allowing SQL Server to create values for me as it goes. I don't have to worry about saving the most recent order number and adding that in. SQL Server is going to do it for me. A foreign key constraint states that the column may only contain values that already appear in the primary key column of a referenced table. These are used to enforce referential integrity. Hey, the orders table has a customer ID column, and that can only contain values from the ID column of the customers table, thus ensuring that our orders always belong to a real customer. A composite key is a key that includes multiple columns. This may be designated as the primary key, provided that the combination of all the columns results in a unique composite value for every row in the table. You will often see composite keys in tables that are designed to relate entities in n-to-n, or many-to-many, relationships. For example, let's start by discussing a one-to-many relationship. We have a customers table and orders table. A customer can place many orders. So one customer, many orders, that's a one-to-many relationship. An order is only ever placed by one customer. So it remains a one-to-many relationship, or many-to-one if you look at it backwards. That can be represented by having a primary key for the customer and a column in the orders table that is a foreign key constraint, referring back to the primary key from the customers table. A many-to-many relationship might look something like this. We have an employees table at the top of the screen and a projects table at the bottom of the screen. Any given employee can be involved in multiple projects. Any given project can have multiple employees involved. So that's a many-to-many relationship. The way this is usually created in the database is to have a table in the middle that relates the two sets. So you can see here that I have this employee ID 52 involved in two different projects, and project ID 57 has two employees in it. So this middle table serves to create the many-to-many relationship. In that middle table, the primary key might be a composite key consisting of the emp ID and the proj ID. So both columns together form a composite key which uniquely identifies each row, even though the rows don't have any other information in them. The relationship relies upon a primary key in each of the employees and projects table. SQL Server has a feature called database diagrams, and they're a common way of managing the relationships between tables. Modifying the diagram actually modifies primary and foreign keys, but it does so in a more visually meaningful way. You'll see several ways, including DDL, on how to create these keys used in production environments. Let's go back to SQL Server Management Studio and spend some time working with foreign keys. To demonstrate a foreign key constraint, I'm going to create a fourth table in my test database. This one is going to represent the individual items that were included in an order, so the order items or order line items. Each line item will have its own ID. And I'm going to allow SQL Server just to make up an identity value for that. We'll just let it do sequential numbers starting at 1 and incrementing by 1, and I'll set this to be the primary key of this table. I also need to know the order that this went with, the stock number that was ordered, and the quantity that was ordered. I want to make sure that my order ID column only draws values from the ID column of the orders table. So that way I know which order each line item goes with. I can do that by right-clicking and going to Relationships. I'll add a new relationship, and under Table and Column Specification, just click this little pop-up button here. I want to draw my primary key from the Orders table, and I want to use its ID column. My local table here will have that in its Order ID column. You'll notice that this says Table 1 because I haven't saved the table yet. I'll go ahead and do that now. If I right-click on Relationships again, I can take a look at that table and column specification and see that the Order Items table's Order ID column can only contain values from the Orders table's ID column. I could also create a database diagram to visually represent that relationship. I'll add Order Items and Orders, and you can see that it's automatically drawn a line. The little key indicates that the orders table is the side that has the primary key, while this little infinity symbol, it's easier to see if you put them next to each other, the little infinity symbol means that there can be multiple items on this side of the relationship. I can actually double click that or right click it or hover over it to see a description of the relationship. Because these relationships can get quite complex, in fact the AdventureWorks one has a very complex one, these diagrams can be quite impressive. Look at that. We can zoom in on any portion of this we want to. Let's go to 100% and then scroll around a bit. And you can see that it really does make it easier to visualize all of these different cross-table relationships. Constraints, generally speaking, are a way for SQL Server to prevent certain kinds of illegal data from entering a table. These are created and applied as part of the database design and are enforced by the server. Attempting to break a constraint results in an error, and the operation is aborted. There are several different kinds of constraints that SQL Server recognizes. A unique constraint ensures that each value in the column is unique. A default constraint provides a default value for the column, ensuring that it will never be null. A check constraint only allows specific data types or specific values to be added. A not null constraint ensures that the column will always contain a value. And the primary key and foreign key constraints we've already discussed. Let's take one more trip back to SQL Server Management Studio and take a look at constraints in table designs. I'll continue using the test database's order items table to demonstrate constraints. Let's start with a default constraint. I want to make sure that my quantity field always has a value, and most of the time my customers only order one of something, so I'll just come up to default value here and put in a 1. I've now created a default constraint. If any user attempts to add a row to this table and they don't specify a value for quantity, it'll default to a quantity of 1, which is better than, I guess, getting an error message. I can also right-click that column to add other constraints, such as check constraints, which will allow me to specify a set of values that are allowed in that column and so forth. So all of these different constraints work together to help ensure that the data in each table is as consistent and as correct as possible. In this lesson, we've covered keys and constraints, including primary keys, composite keys, and foreign keys, and I've given you some understanding of what constraints are and how they're applied in the database design.